All right, we are in 8.3 in advanced geometry. Some real basic stuff at the beginning. If we check this problem out, it says a cylinder has a radius of 5 inches and a lateral area of 30 pi inches squared. What is its height? Here's what a lot of students try to do. They try to draw a picture of this problem, and that's not a bad idea, but it might be unnecessary. It might be a waste of time to draw a picture of this situation. Because would you believe that they gave you one magic thing in here between lateral area, surface area, and volume? Did they give you one of those concepts? Did they like tell you how much it is? Which one of those? They gave us the lateral area of a cylinder. Would you believe that is the particular deal? Here's how this rolls. You will just start with the formula. Grab your yellow card and write that formula down for lateral area of a cylinder. And what's important is you got to put the LA equals first. Like a lot of students leave that off. We need to put that. Isn't it 2 pi r times the height? Isn't that the formula that our yellow card says? Well, they give us some ingredients. All we have to do is substitute those ingredients into this formula and solve for what's missing. I'm going to start with lateral area. Do I actually know it? Do they tell it to me? Yes, it is how much? 30 pi. What you don't put in there is the inches squared. You know, like the label is just a part of it. So 30 pi actually is the lateral area. And then you also know the radius is 5. Are you with me? We are advanced. Don't you think we could take the 5 times the 2 right away in this situation and throw us a 10 pi in that situation? And then isn't it times h? Would you believe we don't know the height? And isn't that totally what the question is asking us, is to find the height? So we started with the formula. Here's a cool trick. Is there a pi on both sides of each equal sign in that case? Guess what's going to happen to those? Because you would like divide both sides by 10 pi, but if there's a pi on both sides, aren't they going to cancel each other out in that case? So we just divide by 10. What is 30 divided by 10, my friends? 3. Then we need a label on that. They were in inches. Would you like to do inches, inches squared, or inches cubed? This is just the height. It is only inches in that case. Only inches, because it's not an area, it is just a height. Wasn't that super easy because we started with the formula? So let's try again. Let's read what they give us here. A right hexagonal prism has a lateral area of 2016 millimeters squared and a height of 42 millimeters. What is the perimeter of the base? When they give you a major concept like lateral area, surface area, or volume, we will start with that formula. This, even though it's a hexagonal prism, isn't it just plain Jane a prism in that case? So find the formula from your yellow card. Lateral area equals perimeter of the base times height. And you should know 2 of those 3 ingredients. There's a lateral area, there's a P, and there's an H in that case. So don't we know the lateral area is 2016? And we don't know the perimeter of the base, but the height is 42, correct? So isn't that simple algebra right there that we would just divide by 42 to find the perimeter of the base? So punching that in. So punching that in, we get 48 for the perimeter of the base. Interesting question. What's the label on that? Should it be millimeters, millimeters squared, or millimeters cubed? It's perimeter of the base. It is just millimeters. How do you feel about all that so far? Not too shabby. Starting with the formula. And yep, as you know, this is the work shown required. You got to do it. So check it out. Let's see if you can start with a formula. Work with a neighbor or pause the video and see if you can get the right formula. And I would wager that we have this formula. Is that what you have? That is correct, but it doesn't do us any good. You know why it doesn't do us any good? Because they're asking us to find the radius, and does this particular formula have an R in it? So this is generic. This is just a generic formula for volume of a cylinder. It's how we need to start, but we need to modify that capital B. Do you remember, it's been a while, what capital B stands for? Area of the base. So can we please change the capital B to the very specific formula for area of the base? What shape is the base of a cylinder? It's a circle. I want the area of a circle. So what should we put in the place of the capital B? Pi r squared. You see how all I have done is rewrite the exact same formula to where there was a capital B. I change it to pi r squared. And you know what? I'm cool if you don't even put the green one. If you're like, hey, I know I'm going to need to like put the actual pi r squared so I could solve for r, like you don't need the generic if you don't want it. So let's sub in. The volume is 1920 or 1920 pi. What is the volume? Don't forget the pi, that's important. And then we have a pi r squared, and we know the height is 30. I didn't want to write an h there. I want to write a 30. Are you guys cool with subbing it? Like, that's the info. First thing I notice is there's only two terms. There's a term right here in blue. There's a term over here in orange. Terms are separated by add, subtract, or equal signs. So there's no pluses, there's no minuses, but there is the equals. There's two terms. Does every term have a pi with it? This got a pi? This got a pi? They're on different sides, so can't they cancel each other out? So I want to cancel those pi's. Peace out, Girl Scout. And here's a bad move. People see that the r is being squared. They're smart enough to know they need to square root to get rid of that square, but you can't square root until you get r squared all by itself. We have to get r squared all by itself. There is a times 30 hanging out with it. How can we get rid of that times 30? Yep, let's take that 1920 over there and divide it by 30, and that is awesome. Not only is that the right move, 64 is a fabulous number. What's so great about 64? Perfect square. So we're going to square root both sides. The radius could be 8 or -8, because if you're really doing algebra, you get plus or minus, but doesn't it make no sense to have a negative radius in that case? Welcome to Advanced Algebra 2. That's called an extraneous answer. If you get an answer that makes sense algebraically but doesn't make sense for the situation you are in. So label, they didn't even give us a label, so what do you want to put? Units. Nice. Let's see if you can start with that one. Give it a shot without me. Please pause the video and give it a try with a formula. Okay. So we gave it a shot here in class. I don't know what they wrote down, but I'm going to take two guesses. Some people could have this in green, and some people might have this in blue. I'm going to actually take a third guess, and some people could have this in red. All three of those work to find the volume of a cube. Only one of them is going to help us find the side length in this situation. Which one of those formulas do you feel is the best one to use in this case? Yeah, we got to use the most specific formula, because watch this. If I put 343 in for volume right here, 343 equals, oh my God, there's 3 stinking letters right there. I don't know them all, right? So I want to just have one variable left. So we want to use volume equals side cubed. So that'll be nice. And if you have Fonny for a teacher, he's been making you memorize some perfect cubes, so maybe some people do know that the answer to that is 7 in this case. But what if it was some number that you didn't know what it was cubed? How do you get rid of a cube? Let's go with the basics. How did you get rid of a square? It's called square root. You get rid of a cube by cube rooting. So to write that out, you make the radical, but it's got a little 3 on what's called the index of that situation. You're going to cube root both sides. But what's even harder is how the heck do you do that in your calculator? Because using the square root button doesn't work. If you have a graphing calculator, I won't lie, there is a cube root button hidden in the menu somewhere. You have to go hunting for it. You have one of them smaller calculators like a TI-34, you probably have a cube root button somewhere right there on your calculator. But here's what you do. To do any root, we're going to do a lot of practice. I'm going to first type in the number that they wanted me to cube root, which in this case was 343, and then I'm going to raise it to what's called the reciprocal power. Do you remember like what reciprocals are, where you just take a number and flip it upside down, right? So isn't the root in this one, like, isn't it being cubed in that case? What's the reciprocal of 3? Not -3, that's the opposite of 3. The reciprocal means flip it upside down. It's 3 over 1. If you flip it upside down, what would that become? 1 over 3. So we're going to raise this to the 1/3 power. For everybody's calculator to do this properly, you should put the 1/3 in parentheses. It really sometimes doesn't matter depending on the calculator you have, but I'm going to tell you, if you slack this off, you will not know how to punch these numbers in your calculator. Please practice with us. Put a parenthesis, 1 divided by 3 in that case. And did you get 7 back in that situation? Raising it to the 1/3 is the same thing as cube rooting. So to answer this question isn't the final guy in inches. But let's practice with some more. Why don't you take the cube root of 64 in your calculator? If you would take 64 and raise it to the 1/3 power, and if you put the 1 divided by 3 in parentheses, it'll work on everybody's calculator. What'd you get back? Did you get 4 back? So is 64 a perfect cube? Yes or no? Try 125. You already know that the answer should be 5. I hope that you remember that one. So we raise things to the reciprocal power to cube root it. And then finally, I shouldn't say finally, but this is the new section that we didn't do much of last year. I believe a lot in ordering concrete. It is one of the most realistic situations where volume is involved. But it is so complicated for the average person to do because it is in like cubic units. So check it out. Let's do some basic conversions first. Basic conversion, how many inches in a foot? 12. If you've had me for a teacher, we've been practicing that all year, stuff you should know. How many feet are in a yard? 3. But this is a question I have yet to really ask you. How many inches are in a yard? Work with a neighbor and see what you think. There are 12 inches in a foot and 3 feet in a yard. How many inches are in a yard? What you got? 36. 3 times 12. Cool? Here's what happens in the real world. We took a big pause in class to kind of talk about cubic yards. So if you would like more help with cubic yards, come on in and see me. But when people order concrete in the real world, even though it is a cubic yard, they just call them yards of concrete. So it is 3-dimensional. But the reason why I say that is because I do a lot of construction stuff, and you'll hear me slip up and just call them yards. Like, how many yards of concrete do we need? It's like, isn't it cubic yards? Yes, it is cubic yards, but most average construction people just call it yards. So here's what we did. These are all true little stories that I made up for you also. The baseball coaches poured a new sidewalk out by the baseball field. It was 6 feet wide, 30 feet long, and 4 inches thick. Think about that. Isn't a sidewalk pretty basically nice and thin? You know, it's not going to need to be a foot deep. Are you with me on that? It only needs to be about 4 inches thick. So it says, how many cubic yards of concrete did they need? Here is the easiest thing to do. Would you believe this is volume, length times width times height? We're just doing like a box situation. How about we change all the dimensions into yards first? Does that sound cool? Can we just change all the dimensions into yards, and then when we find its volume, the answer will be in cubic yards. So 6 feet. What would I need to do to change that into yards? How many feet are in a yard? 3. So let's think. Should this get bigger or should it get smaller? Aren't we changing it to a bigger unit? Isn't a yard bigger than a foot, right? So what should this number have to get to stay balanced? We're going to a bigger unit. This number has to get smaller. How do we make it smaller? Multiply by 3 or divide by 3? We will divide that by 3. What is 6 divided by 3? 6 feet is 2 yards. Are you cool with that? 30 feet, same situation. Aren't we going from feet to yards? How do we convert? Multiply or divide by what? Divide by 3. What do you got? 10 yards. But here's the kicker. That is in inches. Do you know how many inches are in a yard? 36 inches are in a yard. We are going to a bigger unit. Doesn't this number have to get smaller in that case? How do you make it smaller? Divide by 36. And people are like, holy crap, I got to do what? Yep, it's 4 divided by 36. And I'm totally cool if you don't even reduce that fraction. You could leave it 4/36, and I'm going to be happy. But it is a fraction. Do not change it to a decimal, though, because some of these don't come out as nice as decimals. So we're leaving it 4/36, but if you wanted to, that's 1/9. However you want to do it. And would you believe that we are doing concrete, so it is volume, length times width times height. Let's write it down. 2 times 10 times 4/36. You just grab your calculator and you punch it in. If you use parentheses for your fractions, you will have no issues. 2 times 10 times 4 divided by 36. I would get used to punching it this way because those little calculators that you have, you'll stop using those in Advanced Algebra 2. You start using the graphing calculators more. They don't have fraction buttons. You put them in parentheses like that. So 4/36. Hey, this is just a sidewalk. It's 6 feet wide, 30 feet long, 4 inches thick. Should be pretty close to like one concrete truck, which is like 10 cubic yards. What did you get? Not even close to like a big concrete truck, right? It's got to be less than that. So what do you want to round to? Let me ask you this. What if we ordered 2 cubic yards of concrete? Would that be enough? Nope. So we got to round up. Right? We got to round up so we have enough. What if I ordered 3 cubic yards? Is that too much? A cubic yard is huge, right? It's only going to take a little more than 2 to do this whole sidewalk. I don't want to like totally order 3, and then guess what happens when you've filled up your forms and all that? What do you do with the rest of the concrete? You pour it out on the ground and let it sit there and make a rock. You know, you want to move that rock when you're all done? That's a big rock to move. You saw those 27 boxes, right? 27. That's a big rock to move if you don't spread that out right. So we'll round it to the nearest half a cubic yard is what they do in the real world. So do you want 2 cubic yards, 2.5 cubic yards, or 3 cubic yards? We'll say about. So we'll say the volume is 2.2, like cubic yards, but then our order is going to be exactly 2.5 cubic yards. So you tell me what the number you got with the math, 2.2 approximately, and then we're going to order 2.5 cubic yards. So let's see what Seth's doing. Seth's pouring a driveway. That's bigger than a sidewalk. We should get more concrete out of this. 25 feet long, 28 feet wide, and 6 inches thick. Do you know why driveways are thicker than sidewalks? Cars are heavier, right? You know, if you make them too thin, it's just going to crack it. So driveways are at least 6 inches thick, if not 8 inches thick sometimes, depending on what kind of vehicles you're driving on. You go to the interstate is 12 inches thick because of all the semis and how much traffic it does. The interstate has to be thicker because it's just got so much weight on it all the time. And if you do know something about concrete, yes, they put rebar in it and they reinforce it. We're assuming with no rebar, like how we're finding our volume in that stuff. So, all right, so let's convert. How many yards is 25 feet? What do I need to do to that number? Divide by 3? Is that going to come out nice? So we'll leave it 25 thirds. Like, don't put some decimal, right? It's 25 thirds. 28 feet. Don't we need to divide it by 3? Is that going to come out nice? So we will leave it 28 thirds. Nice and simple. Cool. And then 6 what? 6 what? Inches. What do I need to divide that by? 36. You can do 6 over 36, or you can change that to 1/6, whatever you want. But I do want to see you do this. Put them in parentheses and take them times each other. Show me that you're multiplying them together. I didn't even need you to write the formula down because it's just length times width times height. But when you punch that in, dude, you need to put those in parentheses and life will be gravy for us there. So 25 thirds times 28 thirds times 636. More or less than our sidewalk? It should be more. About 12.96, so we'll call that like 12.9. That probably would just round to 13.0. How many cubic yards of concrete should we order? 12, 12.5, 13, or 13.5? Sorry, do I need 13.5? Now, 13 will cover it. You can kind of spread concrete out a little bit. You mix a little more water with it, and it'll thin it out a little bit in that situation. It's just like mixing ingredients. It's like, well, I want it to be a little thinner. Well, I have a little more water, you know, in that case. So 13 cubic yards is awesome. Hey, how many concrete trucks would you need to come to your house? Would one concrete truck be able to carry it all? Wouldn't they have to make 2, right? Either 2 trips or 2 different trucks in that situation. Yes? All right, so let's see what Jay's doing. I will let you guys do this. Read it, and then I'll show you, without having all these blanks to do all the baby work for us, what we'll do. So give it a read. So here's what we'll do. We'll change all these into yards first. I'll show you a different method and see if you like that or don't like it. I'm going to change all these into yards. This is in feet right now. How do I change it into yards? Show me that and put 25 yards. Do the same thing here. All feet, you just divide by 3, so that's 40/3 yards. But this is 8 inches. What do you got to do to change inches into yards? Divide by 36. And then we'll just take those numbers times each other. 25 times 40/3 times 8/36. It's so simple. 25 times 40/3 times 8/36. I'm even scared to show you a different way to do it because it might confuse the heck out of you. Holy cow, how many cubic yards of concrete is this? That's a lot. I usually reevaluate and go, did I do that right? That's a lot of concrete. That's 8 trucks coming. But what did he pour? It's a big metal building, right? How long's the building? 75 feet long. This room is 25 feet long, right? So it's like 3 of these rooms in a row. 40 feet wide. 40 feet wide, this room is basically 20 feet wide. Isn't it like 2 rooms wide that we have right here? That's a big old slab, 75 feet by 40 feet. And then he went 8 inches thick because it's got a big building on top of it, probably designed to hold tractors and big farm equipment inside of it. You know what I'm saying? So it went real thick. So I was like, yep, that looks good. I did my conversions right. That's a lot of concrete, man. So 74 cubic yards, 74.5, or 75 cubic yards. What would you do? We probably better round up to do 74.5. 74 is cutting it a little close. You'd rather have too much than too little in that situation, because if you don't have enough and you can't spread it thin, then you got to order more, wait for them. It might take them 30 minutes to an hour, depending on how far out in the country you are where you're pouring. It's like, dude, this concrete's starting to set up. You do realize concrete, like, gets hard after time passes. You know what I'm saying? So let's do about 70, well, it's not 74.5, is that what I was saying? Label? Cubic yards. Nice. The class is tired of concrete, so we will move on. Please find the area of that triangle. Work together. I would start with a formula. Formula that we got is area equals 1/2 base times height. That is the correct formula to find the area of a triangle. It has a big issue on this particular situation. What is the big issue? We don't have a height. Why is 9 not the height of that triangle? Like if you're using 7 for a base, why is 9 not the height? It is not perpendicular. So what we've done in the past is this. We've tried to do this. We've said, all right, just watch me, because this isn't going to work. We'd like drop a little height in right here, and that's a good idea. Why doesn't that work? Why doesn't it take that 12 and split it into 6 and 6? Why doesn't that work? That triangle has to be very special for it. Starts with an I. It has to be what kind of triangle? Has to be isosceles. It is not, right? We've tried to drop it in like maybe just like this, you know, so it's like, what if we did one of these? That's not going to work because we don't know how long this dude is. We don't have any angle measures to do SOHCAHTOA. We got nothing. So this formula isn't going to work. But here's a question. Does this triangle have an area, or is this impossible? Like, is there an area to this triangle? Yes or no? Yep, so find it on your yellow card. There's got to be a different formula than just area equals 1/2 base times height. What's the name of that formula? Hero's formula. It's actually called Heron's formula. The dude that created this formula, his last name was Heron, but for some reason most people call it Hero's formula. They just drop the N off of it. So here's what it is. Area equals square root of S times S minus A times S minus B times S minus C. Please correct me if I'm wrong. Is that the right formula? What a mess. Very worthless if you don't know what A, B, C, and S stand for. Many students struggle with what S is. It literally tells you on your yellow card what S is right underneath that formula. What does S stand for? Half the perimeter. Cool. And A, B, and C are the three side lengths. If you know the three sides of a triangle, you can always use Hero's formula to find it. So which one's A, B, and C, it doesn't matter. Here's work shown. This is the one formula on the entire yellow card. I could care less that you write it down. I do not need you to write that down because it's just too plain, right? Here's what you have to show for me. Phase 1, find that. What does P stand for? Find the perimeter, write it down. You got to trust me. You can just add them up, right? You don't need work shown for it. Just add them up. 9 plus 12 plus 7. How much, baby? 28. Then right below that, you will find S, because it says S stands for half your perimeter. If the perimeter is 28, what is S? Boom. Please do this. You will thank me. Then you don't need to have that formula written down, but we'll show work like this. You will need a big square root. A lot of people forget about the square root. Then I'm going to sub in. I got S, which is 14, times. What I personally do is I circle a dude and just go around. The dude I circled is A, and then I go around. The next one's B, the next one's C. So I think we can do mental math. It's S minus A. 14 minus 9. How much is 14 minus 9? If you got to use your calculator, I get that, but we're just going to figure it out. What's 14 minus 9? 5. 14 minus 12. 2. 14 minus 7. Are you cool with where those numbers came from? Now, please trust that we're going to have to use this later to do other things. Do not use the square root button yet. Please figure out what's underneath there by taking 14 times 5 times 2 times 7. Just punch that in your calculator without a square root. Only 14 times 5 times 2 times 7. And can you get 980 back? Cool. The most missed thing is people think the area of this circle is, excuse me, not circle, but triangle. They think the area of this triangle is 980. So close. What is the area of this triangle? Not just 980, but, and that is the exact answer. It probably can simplify. I don't give a crap about simplifying it. We're going to leave it the square root of 980. But I do need a label on it. This is in units. So do you want units, units squared, or units cubed? Units squared. So let's get advanced. Welcome to some people's worst nightmare. Find the lateral area, surface area, and volume of this shape. It even tells you it's a right triangular prism. Oh, bro, wake up. Is this a right triangle? It's a right triangular prism. Is that base a right triangle? Talk to a neighbor. What does the word right mean in the name of the shape? That the lateral edge and the base edges are perpendicular to each other. This is what it's talking about, that you have a right angle down there. This is not a right triangle. Cool? So let's do it. Lateral area. Start with the formula. Perimeter of the base times the height. I will continue to write the LA equals. Perimeter of the base is 23. Height is 12. Are you guys cool with where I'm getting those from? Punch that in for me so I don't have to. What's 23 times 12? One person. Thank you. 276. Label. Units squared. Nothing complicated about that. Very simple. Let's try surface area. Going somewhere else, starting our formula. Lateral area plus how many base areas for a prism? When we come back from spring break, we'll have pyramids and cones that only have one basis, so watch out for that crazy stuff. These have two. Sweet. I know my lateral area is 276, so I'm going to just keep on keeping on. I need 2 base areas. Oh no, that is a triangle. And I don't have any right angle boxes in it whatsoever. I cannot use 1/2 base times height to find the area. Do you know all 3 side lengths? Yes. So we will use Hero's formula. Here's what we'll do. We'll find P first, which you have already found. Do you know what P is already? It is 23, perimeter of the base. S is half of that. This is where I'm cool with a decimal. All right, so take 23 divided by 2, and you will get a decimal back. Holy cow. What is our decimal? 11.5. So now we'll do our base area equals. I do not need you to write that formula, but we're going to put all those numbers in. It is S, which is 11.5, times, circle one of these dudes, go around the clock. 11.5 minus 5, bless you, 6.5. 11.5 minus 8, I don't want to do the work for you, so you have to tell me what's 11.5 minus 8. 3.5, and 11.5 minus 10, 1.5. This is going to be a nasty little decimal underneath there. You will not round it off. Type in 11.5 times 6.5 times 3.5 times 1.5, and yep, it will be decimally. Leave that decimal, because it's not nasty, it's just long, but it still comes out really clean. Did you get 392.4375? Came out nice to 4 decimal places, so we will leave that 392.4375, but it's got a square root sign around it. Did I write it down right? 392.4375. Yeah. So let's put that into our formula up here. 2 base areas is, 1 base area is the square root of 392.4375. So, yeah. This is one exact answer. I do not want you to put in the blank because it's too long. That is it. That is the exact answer. It's just too long to fit in this blank to put both the exact and the approximate. So you will show your exact answer in your work shown. Cool, that's where it'll be. And now we'll use our calculator to punch that in. So you just literally hit it from left to right. 276? I can't read. 276 plus 2 square roots of 392.4375. You see you got the square root sign around that and everything. Yeah. It equals. Don't clear that out of your calculator because we'll use it in a second again, but we'll round that to the nearest tenth. About 315 point what? Yep, so about 315.6 units squared. But this over here needs to be written so I can see what your exact answer was. But why did I say don't clear that out? Because of course they're going to ask me to find the volume next. Volume's formula is what? Not quite base times height, but base area times height. And is our base area a radical? Yes or no? Is our base area a radical? Yes or no? Square root is what I mean by that if I haven't said radical for you. So what I'm going to do is pull the old switcheroonie. Radical should come last, square root of 392.4375, and our height is 12. You see how I'm going to write my entire volume as just 12 square roots of 392.4375. Radical should come last. I don't want that in the blank either. It's just too long, so punch it in and we'll put the approximate answer in the blank, but it needs to be written on your work shown. So 12 square roots of 392.4375. Did you get this? Let me show you. That's the right answer, 237.7. What's wrong with this? Why didn't that work? Because when I did the 12 last, you have to either hit over to get out of the square root radical. If you have an older calculator, you have to close the parenthesis up because it started a parenthesis. You got to do that. If you put the 12 first, you will never, ever, ever run into that issue. So about whatever that answer was. 237.7, label. Units cubed. Last thing, man. Let's draw this swimming pool. So we'll draw our box, and we'll put our dimensions in. 8 foot deep, 6 foot wide, 12 foot long. One of those dimensions makes a huge difference. Which one do you think is the most important? The length, the width, or the depth of that pool? The depth. Because if you had to dive in, that's the first question that you would ask. It's like, how deep is it? Is it 6 feet deep, 12 feet deep, or 8 feet deep? You would judge. I don't want to dive in, man, if it's only 6 feet deep. You know, it's like I am 6 feet tall. I really don't want to do that. So 8 feet, make sure you have feet. And then the guy that looks shorter, I'm going to put 6 feet. And the dude that's a little longer, I would do 12 feet. Cool? They ask, how many gallons of water will it hold? That's a very, very basic question of, do you want lateral area, surface area, or volume? Volume. Okay? That is correct. Would you like to find the volume of this pool, get an answer in cubic feet, and then convert it? Because they ask how many gallons will it hold. Convert cubic feet to cubic inches. Are you comfortable with that? Or would you rather just change feet into inches? Which one do you think you could handle with no issues? Changing cubic feet into cubic inches or changing feet into inches? Why don't we just change feet into inches? How about we change all 3 of these dimensions into inches before we get started? So 12 feet, since there are 12 inches in a foot, and I'm going to get, like, go to a smaller unit, don't I need to multiply by 12? Isn't that 144 inches? 6 feet is 72 inches, right? And what is 8 feet in inches? 96 inches. How easy will this be to find the volume of that swimming pool now in cubic inches? It's length times width times height, baby. So let's do that. I will just write down what I'm doing. 144 times 72 times 96. And punch that in. 144 times 72 times 96. Yowie wowie. That is a huge number. You will get marked wrong if you do not put commas in large numbers. Commas go every 3 spaces. So you must put a comma in that large number. 995328. 995328. Work backwards every 3 spots. 995,328. Label, please. Inches cubed. They did not ask that. Mention it again. So to figure this out, I think we set up a proportion. They gave us a conversion rate. I will write it as a fraction. 1 gallon is to 231 inches cubed, correct? Since this is gallons over inches cubed, you will write this other fraction as gallons over inches cubed to keep that balanced. Which one of those 2 things do you actually know? Do you know how many gallons this pool will hold, or do you know how many cubic inches it is? You know the cubic inches, so you can do the 995,328. Since we don't know the gallons, can't we call that X? How do you solve a proportion, baby? Cross multiply. 1 times 9925, blah, 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 is the big number again. 328. That'll equal 231X. You cool with me cross multiplying? What's my move? Multiply by 231 or divide by 231? Divide, so take big boy number, divided by 231. And that came out weird. This is the serious question of the day. How do you want to round that? I will pause the video and let people think. 8 would be okay. So we have decided that we can totally use a decimal amount of gallons. I don't need a whole number. Well, I lost what it was. 8.8 gallons of water. Dude, that's a lot of gallons of water. Could you imagine like taking gallons of milk and trying to fill that thing up? You'd have to do it like over 4,300 times. That's a lot of water. But to end this worksheet real quick, I think that's pretty silly to fill that pool all the way up. Don't you think that's really silly to fill that pool all the way up to the brim? Why would that be silly? People are going to swim in it, right? What happens as soon as somebody gets in the pool? Water spills out. Those gallons of water cost money. I know you probably never paid a water bill, but those gallons of money cost water. Those gallons of water cost money, right? So I don't want to fill this all the way up. So can you see on the next problem, they said they're going to leave 6 inches from the top of the pool. That's going to change our dimensions. But does it change all 3? Does it change the length, width, and the depth, or does it only change one of them? It only changes one of them. Which one does it change? The depth. It was 96 inches deep, correct? So what will it be if we leave 6 inches from the top of the pool? It will only be 90 inches deep. Let's find the new volume of this guy. It is 144 times 72 times 90, because I don't want to fill the pool all the way up, dude. I'm going to leave 6 inches. So we'll punch that in. 144 times 72 times 90. And we'll get that big number of 933,120. 933,120. I don't need you to set up another proportion to figure out what to do with the 231. Didn't you just figure out what to do with the 231? Should you multiply or divide by the 231? We're going to divide. Please put a label of inches cubed on that, though, and then throw me a little divide by 231. Divide by 231. And did you get 4,039.4 gallons, or 5? I wouldn't be mad if you rounded it to 0.5. I'm cool with it, but it really should be rounded down because 0.5 is too much, you know, but it's okay. So about 4,039 what did I say, 4 gallons of water. Dude, how many gallons of water did you save, roughly, just roughly, by not filling the pool all the way up? If you filled it all the way up, you'd get this much. If you didn't, you'd get this much. Very rough math. How many gallons of water did you save? Like 300 gallons of water, right? And if you had to pay for all those gallons of water, you'd be like, yeah, I don't want to like fill my pool all the way up. It's just like filling your bathtub all the way up and then getting in. That's pretty silly. It wasn't that expensive, but it would make a huge mess, and your parents would be very, very mad at you. Cool? What a nice long day.